So a couple of my friends actually wanted me to make a couple of videos, well, a lot of videos, pertaining on, cars and whatnot, because they like the information I give out. And apparently I explain it pretty well. So I'm going to make videos based off of demand on what you want to see. And so it can be anything. It can be car specific. It can be system specific, or how it works, or what you want to know. You can just put it into the comments, and I'm going to answer it, and then I'm going to try and make a video for you as soon as possible in my free time, so you can actually understand how that works. So one of the first things we're going to go over is just the first thing, the general thing about a car. How does a car work? We're going to go through just the powertrain system in general, including stopping. So it's going to be a pretty quick video. It's going to get in depth so you can understand it, and it's going to be broken down to you where you can actually understand exactly what I'm talking about. So everything starts off with your key. It literally starts off with the key. I was literally looking for my own car keys, and here is mine. It starts off with this. This specific key actually has a resistor in it, so when it goes up into my ignition column and I turn it, there is a certain resistance from the actual little control module that's mounted inside the car that is saying. So it knows this key literally does belong to this car. Even though it is cut the exact same, it is making sure that no one is going to just steal my car, because this is the key that it needs, which it can still be stolen very easily, but we're not going to get into that. Once you start it, if you have a stick shift, you press the clutch, turn it, starts. Automatic, cool, just starts. Probably have to hold the brake pedal, but that's okay. Once it starts, you hear the engine, everything's fine. You go ahead, you grab the shifter, you put it in first. If you're a manual, you put it in drive. If it's an automatic, you start driving, you go down the road, you go up to your first stop sign, you come to a stop. There's so many different functions that you literally just use in your car that you did not know. Such as, one, the ignition system. You use the starter. You use the battery. The engine, the transmission. If you have a rear-end vehicle, you have a differential. In the back, if you have a front-wheel drive, everything's built into the transmission. You have a transaxle design, CV axles, drive shafts, independent rear suspension, solid state suspension. If you have a truck, you have a different type of suspension system, drum brakes, disc brakes, steering wheel, the steering system itself, whether it be power steering or electric. There's so many different systems that you literally just use that you probably didn't pay any attention to. It all starts literally with the engine. Without the engine, you have no power whatsoever. If you have a electric vehicle, you still have an electric motor, which is technically not really an engine. An engine is something that uses some form of combustion, but we're gonna right now count it as a engine design. You still have an engine of some kind. You still have some type of motor that that gives power to the vehicle, that is able to move it. It's literally broken down into different types of designs, such as the inline design, the V design, the flat/opposed design, the rotary design, and if you're just a big baller and you have millions of dollars sitting somewhere and you can afford a Bugatti Veyron, then you have a W design. But we're not really going to get into that, because if you're watching this, the odds of you having a W design are very slim, because you probably don't even care how your car works. You just care that it goes fast and you can beat just about anybody that pulls up next to you. The simplest engine design is the four-stroke engine. The four-stroke gasoline-powered engine is the simplest design that you'll find in a car. There are older designs of engines that break down, that are not used in cars, that are either used in motorcycles or farming equipment or things like that, which is your two-cycle. But we're just going to strictly talk about car-based engines, cars and trucks. You have a four-cycle, four-stroke design. What it means is that the engine moves in four strokes. You have intake, compression, combustion, and exhaust. Intake, it pulls in the air and fuel mixture. Compression is literally what it says. It compresses the air and fuel mixture. Combustion, you have a spark plug that sits in there. Spark plug ignites that, and then it forces the piston down. That's your combustion. Then you have your exhaust. The piston then moves up and moves the burned fuel mixture that is completely useless to the car, that it can't help, and it moves it away. The engine overall is literally a giant vacuum pump. That's what it is. It pulls in air and it sends air out. That's all it does. It does absolutely nothing else. It converts the energy it gains from the combustion into movable energy, and so you can move the vehicle. It transverses it to the transmission. So we're gonna move from the engine. and they're going to go to the transmission. So we got to talk what's in between that. How does that work? Is there a shaft? Is there like is there magical fairies or something in there? Is there like a little velociraptor just kind of running around? What's Sean? Tell me what is in that? So if you have a manual design, it is a flywheel, a clutch, a pressure plate, transmission. Literally, it's an input shaft that splines onto the clutch, and all it is sandwiched between the flywheel and the clutch pressure plate. You press on the clutch, whether it be cable or hydraulic or even electronic. You press on the clutch pedal, and all it does is there's a fork. There's a fork. There's a bearing. There's a bearing. It's just called the pilot bearing. And it is linked into the pressure plate. And on the pressure plate is springs that kind of like face out. So I'm just have my hands pointed in. So it faces like this. And all of this is the bearing sits like this. You actuate the clutch fork, and it pulls this spring. When the spring is pulled back, the clutch is able to separate itself from the flywheel. So the engine is doing its thing, it's creating its power and whatnot. So now you got to get the power to the transmission so you can get it to the wheel so you can move your car. So what you need to do is you depress the clutch, because you have to shift the gear, right? You have to shift the gears. You depress the clutch, the engine's spinning, flywheel spinning, clutch goes, splits. This is where you shift your gear. So you go ahead, you put it in first, then you re-engage the clutch. Like I showed you, the bearing and then the actual spring from the clutch pressure plate, you let go, which is the clutch fork, it lets itself go, and it presses back. And all it does, it reapplies that force on that clutch, and when it goes back in, it catches. Now you have a solid state between the engine and transmission, a clutch. It's literally like just a sandwich. So now it's spinning, the transmission's spinning. Now you have an entire transverse movement. So it goes from there and it moves over to your rear end, because obviously your transmission is not directly connected to your wheels, because if it was, only one wheel would be moving, and it would be the weirdest setup, because your car most likely would be spinning around in a circle and doing all sorts of crazy stuff, then you definitely would need help. What it is it's a differential, and a differential is literally just another transmission in a solid state that is a gear multiplier. It multiplies the torque that comes from the engine to the transmission to itself. So it allows itself to use rotational movement, because your wheels, they move centrifugally, and inside the actual drive line, it doesn't really move like that. It's still, yes, it's a shaft and it spins and there's gears and all sorts of stuff, but you have to get it to move out laterally. You have to get that power to the wheels, and your wheels are mounted parallel to the actual body. They are mounted perpendicular to the actual powertrain. So you have to use something to do that. So if you have a front-wheel drive car, you have a transaxle. So the differential is built in. So to easily explain this, we're just going to use the rear end, all right? So inside it, you have a pinion gear, and then you have like the actual gear itself. And what it does is they're a helical cut. Helical means they're kind of like, they look like a little spiral. So if you ever look at ice cream, right? You go to an ice cream machine, and it pours out and it comes out all spirally. It kind of looks like that. And then it meshes up with this other gear. And what they do is this pinion gear itself is mounted to the drive shaft. So the drive shaft's here, then there's a pinion flange that the drive shaft bolts up to, and then on the other side is the gear. And when it rotates, it transfers all that power, all that torque from the engine to the transmission to the drive shaft to this gear, and this gear then turns in a planetary style gear set. And then from there, you have what's the actual differential itself is this little clutch pack. It's a little clutch pack that multiplies the actual torque coming from that, and it sits inside. And then there's drive shafts connected to it, and as everything is rotating, it transfers that movement to your shafts, to your wheels. Literally, that is how your car actually moves. That is how it gets from point A to point B. That's how it starts. That's where everything comes from. That is the simple design of how a car works.